On the agenda for today's uh, webinar, we're going to cover today's resin removal process. So I'm going to highlight what traditional resin removal looks like and go over some of the key pain points associated with these processes. And then I'm going to introduce PostProcess's new solution for resin removal and then highlight the key benefits associated with our solutions. Then I'm going to cover some case studies, and these are some of the most common scenarios that we've run into. Hopefully you should be able to relate to certain aspects from each of these. And then lastly, to wrap things up, I'm going to briefly summarize what I covered and then open the floor to you and whatever questions you may have. So my name is Francesca Baird. I'm the technical trainer over at PostProcess. My background is I have a degree in chemical engineering from the University at Buffalo. Prior to entering the additive community, I spent some time as a process engineer in the automation industry, and I've been with PostProcess for about 6 months now. All right, so I'm going to get started with today's resin removal process. So one of the biggest issues with resin removal today is that there's really no standard process. So you're left to determine what chemicals you want to use, how many steps, and then in what order to get the desired level of clean that you want. This leads to a multitude of issues that we're going to expand upon throughout this presentation. So on this slide, I have an example of traditional resin removal, and this involves a series of chemical baths that we've seen. This one particularly has 4 steps with different chemistries and then finally a water rinse. The chemicals being used create explosive environments that are hazardous for operators. Additionally, the use of IPA leads to additional costs for OSHA and UL certifications for the machines that work in those environments. And lastly, the ineffectiveness of these common solvents lead to a high amount of hands-on time. And also, you're going to be scrubbing those parts as well as swapping out the detergent. This overall is going to lead to more hazards for you. So when you take into account all of the safety and cost considerations associated with a multi-step, highly manual, and in a dangerous environment process, you're quickly going to realize that these processes can't be scaled. If you look down this list, I'm sure you're going to see issues that you're currently running into today. And as you continue to grow your production, the number of these pain points you experience is going to grow as well. So all of these reasons is why we've introduced a solution into this space. So our approach is by combining proprietary software, hardware, and chemistry. These are all specifically designed with resin parts in mind. In your process today, you're likely sourcing at least 2 of these components from different vendors. This is going to create more work for you on top of the fact that these components aren't designed to work together specifically for resin removal the way that the post-process solution is. So the first benefit that I want to talk to you about is the speed of our solution. The speed comes from 2 components, the first being the detergent's quick cycle times. Our detergent successfully removes a multitude of resins in just under 10 minutes. And to validate this claim, we performed field testing on thousands of trays with all different types of resin and all different levels of resin in the detergent. Throughout this testing, our solution consistently processed parts in each scenario under 10 minutes. So then the second component that makes our resin removal system the fastest on the market is our ability to reduce process steps. Rather than multiple chemical baths that have long and inconsistent cycle times, our solution only requires 1 step with our detergent and then whatever you choose to rinse in. We personally recommend water. So now I'm going to show you a list of all of the resins that we have successfully tested that have fallen within that under 10-minute cycle time. And we continue to go out and perform demos. We're happy to test any resins and continue to expand this list. So the second benefit I want to discuss with you is going to be the longevity of our detergent. So we performed a field test specifically to test how many parts we could process before reaching saturation. During this test, we also collected cycle times in order to keep track of how the resin saturation impacted the cycle times. If you look at this graph here, you'll see on the x-axis, we have time, and on the y-axis, we have resin in solution. If you look at the red line here, you'll see how IPA performed in this test. So IPA reached the end of its useful life at just 10% resin in solution, and at that point, cycle times were taking over 40 minutes. Now, if you look at the post-process solution, which is the yellow line, you will see that for up to 25% resin in solution, our cycle times remained under 10 minutes. And then we reached the end of its useful life at 30% resin in solution. So overall, what that longevity means is that our detergent is able to clean 5 times more parts with significantly shorter cycle times than IPA was. However, there is more value to extended detergent life other than just cleaning more parts per batch of detergent. By increasing the detergent's lifespan, you're going to reduce the time you spend swapping out detergent. With the consistency of our solution, you're going to be able to plan ahead for when this swapping out or downtime is necessary. This is further going to optimize your workflow. And since you're going to be spending less time changing your detergent, you'll be spending less hands-on time, which means less risk for accident. And finally, special disposal considerations have to be taken when working with detergents such as these. By producing less waste, we're going to reduce the cost associated with this waste disposal. So overall, the longevity of the solution significantly decreases the total cost of ownership while increasing the ease of solution for you. Now we're going to move on to the reduced chemical hazards. So really, one of our most important goals when formulating our detergent was to make it safer than common solvents being used for traditional resin removal. 2 key metrics that can be used to determine the safety of the environment produced are vapor pressure and flash point. So vapor pressure relates to the fumes associated with the detergent. If you look at this chart here, you'll see that, our detergent has a significantly lower vapor pressure than IPA. What that means is that our detergent emits significantly less fumes. When you're talking flash point, this value is going to be tied to the risk of explosion. So there are industry safety standards associated with the environment produced by a detergent, and our flash point is high enough in order to not require these explosion-proof certifications. Rather, any machine working in the same area as IPA will require those certifications. So overall, the combination of these benefits are going to provide a safer worker environment for you. So here are each one of the hardware options that we offer for our resin removal solutions. So depending on your budget, printer size, and throughput requirements, we offer a range of different machines to accommodate your specific needs. So now we're going to cover some of those typical examples of some ROIs that we've seen. But before diving into the specifics, I want to help you understand the different things that we take into consideration when calculating an ROI. It starts with fully understanding your operation. We evaluate your current print cost and what portion of that cost is due to post-printing. So a few examples of the key numbers we look at are your labor cost, the time you spend processing each part, and then the percent that you damage. So then we compare this to what your post-printing would cost using our solution, and overall this is going to result in the ROI. So the first scenario that I'm going to walk you through today is our Senti in comparison to a single take of IPA. This is going to be a lower volume application. So if you look into the inputs that we consider at just 25 trays per week with a labor cost of $40 per hour, we can save the operator 15 minutes per cycle. So this results in a decreased cost per tray by $3.29. However, we do account for the fact that we are going to increase that consumable cost. So when you tie all of this together, looking at the time savings per week, that's about 6 hours, and that results in a $300 savings per week. So when you work this out, that equals to being a 35-week ROI for this circumstance. So the second scenario I'm going to bring you through is a high volume application. So this will be our DEMI in comparison to multiple tanks of IPA and TPM. So in this case, they were printing 140 trays per week with the same labor rate of $40 per hour, and we had the ability to save them 23 minutes per cycle. With this time savings, we decreased the cost per tray by $2.51, even when we took into consideration the fact that we did increase the consumable cost. So overall, with all of the time savings, that was 27 hours per week. We ended up saving this user about $1,400 per week, resulting in a 31-week ROI for our DEMI. So now I've touched on all of these benefits, but I do want to reinforce this concept of our additive manufacturing expertise. So we can be a resource both pre-sale to be sure our solution is right for you, and also we will provide you industry-specific support for the lifetime of the solution. So we can be a resource for you as you continue to scale and expand your printing operations. All of the information that we have, we'll be happy to support you with and continue to grow together. So lastly, all of these benefits combine to provide the consistency necessary to optimize your process and plan your workflow. We're going to remove the bottleneck created by traditional resin removal and allow you to grow your operation. And lastly, by reducing the tedious manual labor, our solution is going to free up your time for more value-added work. So if you think you could be a good fit for one of these solutions, you can contact Fisher at marketing@fisherunitech.com or call the number you see here. And now I'm going to open up the floor to any questions you guys may have.
If anybody has any questions, just feel free to type them in the Q&A section right there below the participant list.
Okay, so for one of the questions that are coming in, someone asked to see the resin slide again. So I'm going to go back to that. And like I said before, this isn't all of the resins that can be used. These are just all that we've had the time to test. So if you have any other resins you would like us to test, we are happy to do so and continue to expand upon this list. So one of the questions is, have you tried it on Formlabs Durable? And do you process after curing or before? So for that, we have tried it on Formlabs Durable. There's a couple of the Formlabs resins we've listed here. And we process prior to curing. And these are another question that came in, are these thermosets or thermoplastics? These are thermoplastics. So I have a question about Stratasys FDM machines, and have we done any work on their materials? So we've done extensive work with Stratasys FDM machines. We have soluble support removal solutions for that. If you go on our website, there's a bunch of different material that you can gain access to for further information. I have another question here about distillation. So we have shown success with the distilling of our detergent. We're seeing a yield of about 70%. So we have a question here about how often the detergent needs to be changed. So that's really going to depend on the volume of your throughput. So one way you can tie to that is depending on how much you're doing, how many grams of resin in solution. So if the one slide that I mentioned was we can handle up to 30% resin in solution, so you're able to use it up until that level of saturation. I can't give a particular timeline because it's really going to be heavily dependent on what you're post-processing. So we have a question here about the price ranges. And for that question, I'm going to have you contact Fisher directly. There's another question here about if you need to take the parts off the tray. So that's going to depend on what solution that you choose. So our different envelopes for each machine is going to align with different printer envelopes and tray sizes. So you can align these trays to the printer size if you want to. If you have a lower volume application where you don't need as big of a solution, you don't need to, but we do have the ability to process trays if you get a machine that your trays will fit into. So I have another question is if these solutions are eco-friendly. So our PG 1.2 requires special disposal considerations. It's going to be heavily dependent on where you're located. So make sure that that's something that you discuss with either your Fisher representative or somebody at post-process to make sure you adhere by your local guidelines. I have a question here if we do SLA support removal. So this solution specifically is doing resin removal. These supports are still break-off supports, so we won't be removing the supports, just to be clear. I have another question regarding if the solutions are recyclable. So that goes back to the distillation. So if you have the ability to distill our detergent, it can be distilled for a yield of up to 70% can be reused. Of course, happy to be here. I appreciate it. Anybody else has any last questions? Please feel